Hello everybody, this is going to be a quick overview of the 5.1 Intro to Unit 5 Equations and Inequalities lesson that you can find on Canvas. I think on Canvas it's called 5.1 Introduction to Unit 5 with Tape Diagrams. Our learning target for this lesson is I can use a tape diagram to find an unknown amount in a situation. So we started this lesson talking a little bit about what this unit is going to look like. So we talked about how in our prior unit we were working with expressions which could not, or it could be simplified, but could not be solved, right? We were combining like terms, we were factoring, we were expanding, we were using the distributive property, we were moving terms around, but we could not solve for our variables. However, we are moving into a unit where we will be looking at equations and inequalities. And these can be solved. They can. And we talked about first, we're going to be looking at equations. And equations are anything with an equal sign. And I think of these as a balanced scale. So I drew my bad scale, and we can imagine we have this scale in perfect balance. So I might say if this side equals 4, then that means this side could be like 2 plus 2, right? This is in perfect balance. It is not tipped. And we will be talking about inequalities later in this unit, but for now I'll leave it with that because we are going to look at equations. So this example, we're looking at just what the goal of solving an algebraic equation is. And so when we are solving an equation, our goal is to isolate our variable. And again, that isolate means that variable wants to be all by itself. And so if we are asked, for example, to solve for x in an equation, what you are trying to do is manipulate your equation so that you end up with one positive x, emphasis on positive, being equal to an amount. So in this example, we see a scale, and on this side, we have 2 x's, and on this side, we have 4 1's. And this little x down here is saying, excuse me, I would really like to be alone. And so I'm asking you first, what equation is being modeled here? And we can think of the middle of this scale as an equal sign. So if the middle of that scale is the equal sign, then we're saying one side of our scale is equal to the other. So we are going to say that this is 2x equals 4. And again, our goal here is to balance the scale in a way where x is all by itself, but we don't disrupt the balance. And so what we came up with in class was there were a couple things we could do. But the easiest way to look at this is if we are using this equation, 2x equals 4. So we can pop our little t-chart down and notice that if we divide each side of our equation by 2, then we will end up with one positive x on one side and a number on the other. So let's try it. Divide that side by 2. We don't want to disrupt the balance, so we have to divide that side by 2. If we have 2 x's divided by 2, we end up with 1x, and that will equal 4 divided by 2, which is 2. So we are solved. We have one positive x equals a number. So we are looking in this specifically at these things called tape diagrams, which I know many of you have seen. We've worked with them a little bit this year, and I'm pretty sure you saw them last year if you were at Hosford. But I'm giving you these first 2 examples, and in class we were asked to first just observe these diagrams. We were asked what we noticed, what did we wonder, and the most common thing that people noticed was that it was only variables being used, right? No numbers, only variables, and that there were parts being combined to make a whole. And what we can see there is, like, in the first situation, we have 4 sets of A plus B. And when they are combined, we get C. In the second one, we have these 4 X's, and then we have a Y. And when those are combined, so those are our parts, we get Z. So we started talking about how can we build an equation out of these. So some people notice, well, if we have 4 A's added to 4 B's, we could call this 4A plus 4B and set that equal to C. Or we could look at this as the distributive property, saying we have 4 sets of A plus B. So we could say, well, this is the same as saying 4 times A plus B, and that will equal C. And we did the same thing for this second diagram. We said, well, we have 4 X's and a Y. So we could say 4 X's plus Y, and all of that has the same value as Z. 4x plus y equals Z. If these were on a scale, and Z was on one end of the scale and 4x plus y was on the other, that scale would be balanced. That is what that equal sign means. So on our next slide, we made these observations, we wrote these equations. Then I asked you all, what were some possible values for A, B, and C that make this true? What are some possible values for X, Y, and Z that make this true? And we talked about how did we decide which values to choose. So again, I'm just going to write down the equations we were working with. So we were working with 4 sets of A plus B equals C. And we were working with 4 X's plus 1 Y, and that all equaled Z. So what was happening is most students, we'll just start with this first example, were just picking random numbers for A and B. So I'll just do the same thing. I'll say, well, I'm going to say A equals 2. And I'm going to say B equals 3. And then that will force C to equal something if I plug those values into my equation. So my equation is 4A plus B equals C. So instead of A plus B, I'm going to say 4 times 2 plus 3 is going to equal C, which is 4 times 5 equals C, which means that 20 equals C. So there are 3 terms that work. We can really pick any value at all for A and B, and we will get the C that matches. There are infinite possibilities. Try a few. Just pick anything you want for A and anything you want for B, solve it as this equation, and see what you get for C. And we can do that exact same process for our second tape diagram. We have 4 X's plus a Y is going to equal a quantity Z. So let's just give X and Y a quantity. Let's say that instead of X, we're going to say all of our X's are going to equal 1/2. And our Y is going to equal 3. And we don't know yet what Z is going to equal, but we can find out by using this equation, 4x plus y equals Z, and let's just see what we get. So instead of 4 x's, I'm going to say 4 times 1/2. And instead of y, I'm going to say plus 3. And that's all going to equal z. And then I can simplify that. 4 times 1/2 is 2, plus 3 equals z, which means that 5 equals z. So when we set x and y equal to any number, that will force us into finding the corresponding value z. Once again, try a few. Just like pick any number for x, any number for y, and then see what you get for z. So this is the general structure of how to use a tape diagram. So now let's look at an example of a word problem. So in this word problem, we have May. So May made 50 flyers for 5 volunteers in her club to hang up around the school. She gave 5 flyers to the first volunteer and 18 flyers to the second volunteer, and then divided the remaining flyers equally among the 3 remaining volunteers. And I asked you all in class where you saw the parts of the story represented in the diagram. And I got a lot of excellent responses. Some people said they saw that 50 right there represented the total number of flyers. Some people noticed that we have 3 X's right here and said that those 3 X's represented the number of flyers given to the 3 remaining volunteers. Oops, I spelled flyers wrong, whatever. Flyers given to last 3 volunteers. And then people noticed that what we had left was we had this 5 plus 18, which represented the number of flyers already handed out. So we had 5 plus 18, meaning flyers already handed out. Okay. And so then we were asking, well, how can we then find our unknown value? And that unknown value is x. How can we find that? And we saw multiple methods coming out. And one of the ones I really liked was that students were seeing that, well, if this whole quantity, all of this equals 50, that let's just split this up into 2 groups. We have the group we don't know, which is this one, and we have the group we do know, which is 5 plus 18. So 5 plus 18 equals 23. So we know that this represents 23 flyers, and then we could say 50 minus 23 is 27. So we know that this portion right here is 27 flyers. So these remaining 3 volunteers were given a total of 27 flyers, and the word problem says that they were equally distributed. So if they're equally distributed, we can write ourselves a little equation. We have 3 x's, so we can say, well, 3x, and that equals 27 flyers. And then we can do some quick algebra. If I want to know what 1x is, I'll just divide each side by 3. 3x divided by 3 is 1x. 27 divided by 3 is 9. So x equals 9. And what that means in this story is each volunteer, or each of the last 3, got 9 flyers. So that was one way I saw people solve this. And there are multiple ways. You can also write an equation. You could say, well, I have 5 plus 18 plus 3x all equaling 50. And then you could do some solving with that. You'll get the exact same problem. you can do another way. Really, we're just trying to make sense of these situations with a tape diagram. Let's look at one more example. So in this example, we have our old friend Billy Bob, and today he's feeling hungry for apples, and so he bought 4 bags of apples. Each bag had the same number of apples in it. After eating 1 apple from each bag, he had 28 apples left. Hooray! Billy Bob loves apples. So I asked you all to look at these 3 tape diagrams and decide which one of these best represents this situation. So go ahead and pause, look them over, see which one you decide. And what we agreed upon was that C was the best choice for this situation, in fact, the only choice. And the reason is it tells our story. It says that we have 4 bags of apples. Right, there's 1, 2, 3, 4 bags of apples. Each minus 1 because he ate it. Billy Bob ate 1. And totaling 28 apples. So we see the story modeled there. We see 4 bags of apples minus 1 equals 28 left over. And what X represents in the story is apples per bag. And so there are multiple ways, again, that we can use to solve this. And I'm going to share one that I really liked that was just using the diagram. So a lot of people noticed that, well, if we're trying to figure out how many apples were in the bag to begin with, let's pretend that Billy Bob didn't eat any. And let's add 1 back to our total. So after he ate 4 of them, he had 28. So if we just create some zeros there, by adding, and we can say 28 plus the 4 he ate, means he actually had 32 to begin with. And so then we can say, well, if he had 4 bags of apples, so 4 times X, then he had 32, and then we could do our little t-chart. We can say, well, we'll divide that by 4, and we'll divide that by 4. So X equals 8. So he had 8 apples per bag. There are a lot of other ways we can do this, but I really liked that method because it really used the diagram. And so one last thing we talked about is, since C was the correct story, why were A and B incorrect? And so I asked, what is a potential story being told by A? And some students came up with some really fun answers, but one of the answers was, well, Billy Bob went and bought 4 bags of apples. So there's 1, there's 2, there's 3, there's 4 bags of apples. And as he went up to the register, he won an award where they got to add 1 free apple to each bag. Cool. So Billy Bob then had 28 total apples. Awesome. And then for B, I was like, well, what story is this telling? It's like, okay, well, he's still buying 4 apples. There's 1, there's 2, there's 3. So Billy Bob went and bought 4 bags of apples. And then as he was walking home, he found a tree and there was 1 apple on it and he picked it. So then he had 28 total apples. So he had all the apples from his 4 bags plus the 1 extra. So each of those tells a different story. Only one of them tells the one we were given. So those are the examples we went over in class. Please email me if you have any questions, and in my next video I'll go over your homework.